Hello students, in this video I will be going through 4 examples where I will be solving problems involving compound interest. Let's take a look. So the question here states that Scott invests $4,347 in a retirement account with a fixed annual interest rate of 4.33% compounded 2 times per year. What will be the account balance be after 15 years? So let's take a look. So in order for you to solve this or be successful at solving these types of problems, it's to be able to identify the types of information that's given. So here for 4347, this is our P. This is P. 0.433, that's R. And 15, that's our T. And 2 times per year, that's our N. So this guy right here, that's N. So how do we solve this? So according to the equation, the compound interest equation, I have 1 plus R over N to the NT. I want to make my substitutions, right? I'm solving for A, so it's 4347. 1 plus, I need to convert the 4.33% to a decimal, so it's 0.0433 all over 2 to the power of 2 times 15. And what I need to do is I got to evaluate this. So I'm going to go to my calculator. So I have 4347, open parentheses, 1 plus 0.0433 divided by 2, close parentheses, to the power of 2 times 15, 8265.20. That's how much it will be in the account after 15 years of only depositing $4,347. Let's take a look at another question. Julia invests $28.31 in a savings account with a fixed annual interest rate of 7.8% compounded 6 times per year. How long will it take for the account balance to reach $3,859.82? So A in this case is given, and that's 3859.82. P is also given, that's 2831. R is given, and it's appreciating, it's 0.078. And N is also given, is equal to 6. We need to figure out how much time it will take, so we're looking for T. So in the equation, A is equal to P times 1 plus R over N to the NT. We're going to make the appropriate substitution. The only unknown in here is T. So it's 3859.82 is equal to 2831, open parentheses, 1 plus 0.078 divided by 6 to the power of 6t. I need to solve for t. I'm going to divide both sides by 2831. So 3859.82 divided by 2831 is equal to 1 plus 0.078 divided by 6 to the power of 6t. I want to take the log of both sides. And if I do, I'll end up with this. And according to the power rule, the 6t can come out in front, and everything else remains. That's the beauty of logarithms. The unknown exponent becomes a coefficient. So then I can now perform reverse PEMDAS. Divide both sides by 6. Divide both sides by 6 log of 1 plus 0.078 divided by 6. So if I take If I divide both sides by that, I end up with t is equal to, I need more room, this whole thing divided by, whoops, divided by this whole thing. Of course, excluding t, that is. So this is the value that I need to enter, and actually this is the exact answer here. So let's punch that in. Log of 38, I forget the number already, 59.82 divided by, open parentheses, 6 times log 1 plus 0.078 divided by 6. Enter. That seems really odd. 106 years does not sound right. So let me take a look at what happened here. 2831. I forgot to type this in. Divided by 2831. That would make a big difference. So 4 years. Okay, so it would take 4 years for the account for that investment account to go to 3,859. All right, moving on. Nataly invests 4118 in a savings account with a fixed annual interest rate compounded 3 times per year. After 5 years, the balance reaches that amount. What is the interest rate of the account? So in this case here, P is equal to 4118, and A is equal to 5072.89, and T is equal to 5, and N is equal to 3. Now we got to figure out what is R equal to. So according to the formula, A is equal to P times 1 plus R over N to the power of NT. I want to make my appropriate substitution, and I have 5072.89 is equal to 4118, 1 plus R over 3 to the power of 3 times 5. So now I need to work my way to getting to R. So I'm going to divide both sides by 4118. Whoops. Is equal to this. I want to take the 15th root of both sides. So I want to take this and raise it to the power of 1/15. And that will equal to 1 plus R over 3. And subtract by 1. And multiply by 3. So R will equal to, whoops, running out of room here, so I want to move this next problem over. So I want to end up with -1 is equal to R over 3, and I want to multiply both sides by 3. So I end up with this. R is equal to this massive thing. So now we just got to figure out what this is. So 5072.89 divided by 4118, and close that in parentheses. I want to put in a double parentheses. Why? Because I'm going to multiply this whole thing by 3 in a moment. Raise it to the power of 1 divided by 15. Subtract 1. Close parentheses times 3. I believe that's it. Let me just double check. Yes, it is. Press enter. So R is equal to 0.04199. Or R is equal to 4.2% per year. Let's take a look at the last one. Kristin invests a sum of money in a savings account with a fixed annual interest rate of 8.68% compounded 2 times per year. After 7 years, the balance reaches that amount. What was the amount of the initial investment? Okay, so 2532.26 is the current value. The initial is what we're trying to solve for. I don't know what that is. 1 plus 8.68. It's still appreciating, so it's 0.0868 divided by n, in this case, is 2 to the power of 2 times 7, because t is 7. Now I just got to solve for the initial value. So actually, p will equal to 2532.26 divided by this whole massive thing. And that's what I want to enter to the calculator. 2532.26. Or actually, yeah. 2532.26 divided by open parentheses 1 plus 0.0868 divide by 2, close parentheses, to the power of 14. And then enter. 1397. 1397 is my answer. There you go.